Alright, geometry peeps, here we go. Chapter 3. Let's get it. Alright, geometry, identifying lines, transversals, and angle pairs. The first word we're going to learn today is probably something you've heard before, and that is the word of parallel lines. Now, parallel lines are lines that are in the same plane but do not intersect. So no matter if they went on forever, they would never ever cross. Okay, now, some notations. When we're talking about lines, we could say line AB is parallel to line CD. So these two lines straight up and down next to each other are what reflect our parallel lines. And when they're drawn in a diagram, so let's say we have two lines, sometimes they put little arrows on them. So this would indicate that these lines are parallel if we didn't have a statement to tell us, or even sometimes they look like this. So any of those three notations will tell us that lines are parallel. Lines, remember, that are lines in the same plane that do not intersect. Same plane is key. Now, the next word we got is perpendicular. Oh, can't spell. Perpendicular. Now, perpendicular lines are also lines in the same plane that cross to form a right angle. So they intersect to form a right angle. So the notation we use here is AB is perpendicular to CD. So what that looks like in a diagram is they cross exactly at a 90-degree angle or right angle, and to indicate that on the diagram we put a little square there. So that would indicate perpendicular. Now the last one we talk about is skew. Skew lines are not in the same plane and do not intersect. Now skew lines are a little different and you probably haven't seen them before, so the best way to show you is when we get down to the diagram here. So in this diagram we're going to talk about parallel, perpendicular, and skew lines. So you really have a concrete example to understand it. So the first one we're going to talk about is parallel. Now remember, parallel lines are lines in the same plane that do not intersect. So in order to be on the same plane, we need to look at lines such as VR and pretend that they go on forever. And lines TS. Okay, they're in the same plane, that top of the figure there, and they would never cross. So line TS, and that's actually a line segment, so we have to be careful with our notation. TS is parallel to line segment VR. Alright. Let's name another pair. Let's go to another plane, so maybe RD and SC. So RD is parallel to SC. So no matter which way they're going, as long as they're going the same way and don't cross. I think you get the point. We could go on and name a bunch of them based on this diagram. So perpendicular lines would be two lines that cross to form a 90. So an example of that would be those two. So VA would be perpendicular to AD. And we can label that in the diagram by putting a little square like that. Alright, another example we could go SC and DC, RD and DC, any of those there. We go the back here, TB and BC. Alright, so any of those combinations will work as well. Okay, now for skew. Now the way I like to think about skew is they're not in the same plane. So think of two lines that would normally cross, but because they're on different levels, they don't cross. Alright, different levels works for me. So let's say, for instance, VR. If this line were to go on forever, now let's look at like AB now. AB's down here. So one's going left to right at the top, and one's going front to back in the bottom. So they're going opposite directions, but because they're on different levels, different planes, they actually do not ever cross. So VT, I'm sorry, that's not VT. VR and AB are skew lines. Alright, and again, the way I like to think about it is just different levels. Okay, moving on. Now, transversal and angle pairs. This is a very important concept that's going to be with us the rest of the unit. So just try to grasp this as close as you can, and we're going to review it in class tomorrow, and the next day, and the next day, and this stuff's not going away. So the first thing, let's talk about some vocab. I want to talk about this word transversal. Now, transversal is a line that intersects two or more lines in a plane at different points. So down in our diagram here, this would be our transversal. It's one line that intersects two or more, so we could draw a third line here if we wanted, and it crosses at 3 points. Alright, so that's our vocab, but let's not draw all over this too much because we're going to need it to list all our angle pairs. So The first thing we're going to talk about is interior angles. Now, let's number our angles real quick. Put 1, 2, 3, 4, 5, 6, 7, 8. So we're going to reference these 8 angles by their number for the next part of the lesson here. So those aren't going to change. Now, first thing I want to talk about for interior angles. Now, interior means inside. So I like to think of these two lines as what I call my sandwich lines. If this was a sandwich, which numbers would be inside the sandwich? And which numbers would be outside of the sandwich? So interior, we're going to focus on the numbers inside the sandwich. So my interior angles would be angle number 3, 4, 5, and 6. So my angle numbers 3, 4, 5, and 6. Alright. Now, let's just focusing on those 4 angles, 3, 4, 5, and 6. Let's talk about it. Alternate interior angle. So alternate means like to switch or to flip-flop. So an alternate interior would be like on opposite sides of my transversal. So 3 and 6 is what we would call an alternate interior angle relationship, and 5 and 4. So we could say angle 3 and angle 6 are alternate interior angles, as well as angle 4 and angle 5 are alternate interior angles. Alright, so that's that angle pair there, and you have to be able to identify all these angle pairs. So the next one is consecutive interior angles. Sometimes they're called same side interior angles. Alright, now we're still focused only on the 4 angles on the inside, but now the same side makes more sense, but consecutive is the fancy math term we get, and what that means is they are on the same side of the transversal. So 4 and 6 are on the inside, they're interior, and the same side of the transversal. So angle 4 and angle 6. Also, angle 3 and angle 5 would be on the same side interior. Alright, so it kind of makes sense. Everything inside, alternates flip-flop the transversal, and consecutive is the same side of the transversal. So identifying that transversal is a very important part of this. Okay, then lastly we have exterior angles. Well, if our sandwich lines are the same, and those are on the inside, my outside are going to be the top and the bottom. So 1, 2, 7, and 8. Angles 1, 2, 7, and 8. So now we're looking at the outside of those lines, and the same idea. Alternate exterior, we would jump across the transversal. So angle 2 and angle 7, and then you could go the other way as well. 1 and 8. Angle 1 and angle 8. Alright, so those are my alternate exteriors. Now again, consecutive exteriors, also same side, alright, are on the same side as the transversal. So for instance, angle 2 and angle 8. Angle 1 and angle 7. Alright, so that's how we deal with interior and exteriors. And lastly, we have corresponding. Now corresponding, it means exactly that. Which angle corresponds as it's with itself. So think of these as like a pair of 4, and think of these as a pair of 4. Who's in the same spot? So for instance, 1 is in the top left corner of this pair of 4. Or, I don't know, not a pair, but this group of 4. And in this group of 4 down here, 5 is in the top left corner. So 1 and 5 correspond because they're in the same position. The same position. So angle 1 and angle 5 are corresponding. Also, we would have angle 2 and angle 6. They're both in the top right position. Angle 2 and angle 6. Then let's look bottom left, angle 3 and angle 7, bottom right, angle 4 and angle 8. So if I say, give me a pair of corresponding angles, you have to be able to name it. Give me a pair of alternate exterior angles, you need to be able to name it. Alright, and that's where we're going to start tomorrow in class. See you then.